Okay, so we're looking at blood pressure. That's not how you spell pressure, is it? Last I saw, no. How about that? So blood pressure homeostasis. And this occurs through baroreceptors, right? So we have baroreceptors, those are over here. We know they're stretch receptors. And they monitor stretch over here in the carotid sinus and the aortic arch. So they send impulses back to the cardiovascular center. Okay, so they send information back to the cardiovascular center through impulses. So if we look over here, just a second, better color. So let's look at blood pressure. Let's look at action potential and the response. Where these colors are coming from. All right, so baroreceptors are going to send back impulses to let the cardiovascular center know what's happening with the blood pressure. So in normal blood pressure, there's going to be a certain number of action potentials that occur. Okay, so let's say it's 10. So action potential, here's little action potentials coming down here. Okay, and let's say the normal number of action potentials that basically tells the cardiovascular system that blood pressure is in a homeostatic range is 10. Let's just say it's 10. Okay, so if the cardiovascular center is getting its 10 action potentials, what will the response be? Well, the response will be nothing. It's fine. It's in homeostasis. It's happy. It's good. Okay? So, what happens if the blood pressure goes up too much? Okay, so it's increased. All right, so that would mean that the action potentials are more. So let's say 30. So now there's 30 action potentials coming over here. Okay, so that means that the blood pressure is up. We're feeling a whole lot of stretch here. Okay, so what is the response? So the response, we need to slow it down. So it would be a parasympathetic response. Slow it down. What if the pressure was down? So that would mean the action potentials would be less. Let's say 6 instead of 10. The response would be a sympathetic response. Speed it back up. Okay, so that's how it would be controlled. So how does that happen? Okay, so we have parasympathetic, response, and the sympathetic. Sure is light, isn't it? So what happens here? Okay. Well, what happens with the heart? Let's look at that first. So what's happening with the heart? Well, if the pressure is normal, obviously nothing. But if it's too high, we get a parasympathetic response. So if it's too high, then parasympathetics say the parasympathetics will decrease heart rate to the heart. They will decrease stroke volume within the heart. Okay? If the sympathetics, if the blood pressure is too low, the sympathetics take over, and what happens? Well, we get the opposite: increased heart rate and increased stroke volume. So that's for what's happening with the heart. Okay, so what about with the vessel? So what happens with the vessels? Well, sympathetic, pretty easy and straightforward. We're going to increase resistance. So we increase resistance through vasoconstriction. And that will increase pressure. Parasympathetically, that means pressure is too high. So what do? Decrease resistance. So vasodilation. Okay? But there's something weird here. If you've picked up on it, only the sympathetics innervate the vessels. Okay? Parasympathetics do not innervate the vessels. So how do we get vasodilation through the parasympathetic system? Through chemicals. It secretes or sends out a chemical called nitric oxide, which is a strong vasodilator, and that will cause vasodilation and will decrease the pressure. So basically, that's a pretty good overview of how pressure through both, this is both heart and both vessel, how it is controlled to maintain homeostasis.